and substitute it here. The final shape for the formula will be y equal x squared minus x. Now there is another situation, okay? There is another situation when we have q of x multiplied by y rises to power more than 1, okay? In this way we will need to use what we call it Bernoulli, okay? Bernoulli solution or method. Okay. The idea came from where? That we know that dx over dy is function of x and y, and when we have y is g of x and z, okay, then we can convert it into g of x, x of z, because when we differentiate with respect to x it will be 1, and gz of x of z by dz over dx. It's coming from uv equal u dash v plus vu dash. I will convert this function from x and y into x and z, everything, and rearrange. It will be linear. Oh, now from here all these steps is just to convert non-linear into linear, so I can solve it as a linear. But just a minute, when you solve it as a linear you will get z, you will not get y. Yeah, I know, but later on I can convert and back to y. It's like algebraic substitution. Okay, the way, the method for the Bernoulli equation is, see here, dy over dx, p of xy is fine until now, f of x, or let me say q of x, multiplied by y to rises to power n. Y rises to power n, when n 0 or 1, it's fine, it's still linear, because I can take it to the other side, left hand side, and take a common y, and it will be fine. But the problem when n is greater than 1, 2 and above. In this way we cannot solve it directly, we go for Bernoulli. Okay, Bernoulli started from assuming another variable which is z, where z is y to the power 1 minus 1. Convert the whole equation into z, solve it as a linear, and back to y. Let's do it in this example. Now see here, x dy over dx plus y, x square y square. If I divide by x to simplify, I'm here. Now this is p, but see here, this is f and this is y to the power 2. Since I saw y to the power 2, I remember Bernoulli. Then directly I will say, okay, z equal y 1 minus n. And since n is 2, 1 minus 2 is minus 1, so this is z. Okay? dy over dz, then if I differentiate, it will be minus z to the power minus 2 dz over dx. I will convert the whole equation here from x and y to x and z. It looks like this. Now let's have a look at this part. dz over dx, and this part is p, and this part is q. Oh, this is linear. I apply linear procedure. Integrate, exponential integration, this part, okay, minus outside d over dx is ln, minus, it will be here minus 1, ln with exponential x to the power minus 1. Then I came to solve it, multiply by minus 1 the whole equation, and simplify and solve. As we learn in linear, I got z. Now when I got z, you know, this is z. I back to substitute by y to power minus 1, which is 1 over z, and simplify. Now I got the final answer as y function of x. Now differential equations are available in our world in many applications, many specialities. I will give here just a few examples as applications for differential equation. I will start first with this example. Let's read it and work on it. A population grows at the rate of 5% per year. How long does it take for the population to double? Use differential equation for it. Now if we assume that the initial population was p naught, okay, and the variable is p with time, okay, then I will say, okay, population, rate of change of population is 5% by the original population. Okay, let me simplify. We are here, cross, and let me say do separable. We are here, integrate. As you can see here, we got the final formula. Okay. Now I need initial condition to solve. He told me that the question at time 0 we have p naught, the original. It become double later on. We want to see when it will become double. Then I will substitute for time 0 p by power p naught. I got c. I'm back and substitute by c. This is the new formula. Now next he told me that when the time, talking about the time, it will be double the power, double p. So this means that double p naught. P naught with p naught, it will be 2. So this is the time required to be double the population. Another example, the slope of tangent at a point pxy on a curve is minus xy. It means dy over dx. Tangent or slope or gradient is dy over dx. If the curve passes through the point 3 and minus 4, find the equation of the curve. As you know, dy over dx equal minus x over y. He gave it to me in the question. Cross multiply, integrate. This is separable, easy and direct. I got the implicit solution in this way. Okay. Now he gave me initial condition x and y. I substituted to find c. Then I find c. And back here it was 25. I back to substitute here its value 25 over 2. Another example. A tank contains 300 liters of fluid in which 20 grams of salt is dissolved at 0 time. Oh, this is the initial condition. Brine containing p 1 gram of salt per liter is then pumped to the tank at the rate of n equal 4 liter per minute. The well mixed solution is pumped out at the same rate. Find the number n of grams of salt in the tank at time t. And he gave you the formula. Just a minute. This is the formula. When I simplify, okay, cancel this with this here, it will be 75. Simplify and rearrange, we got this formula. Oh, this formula remind me with linear equation. So I will take p is 1 over 75. Sorry, here also variable is p, but p of x, I mean the part here, is 1 over 75. When I integrate it, it will be t over 75. Now the solution is p of t by exponential the integral, and the right hand side by the exponential. When I integrate, it look like this. Now I need to find c. He gave me initial condition. At 0 time, the number of grams is 20. So I will substitute, as you can see here, and simplify. We got c. Okay, we got c. Then back and substitute c for here. You have the final equation. Another example from electrical circuits. Find the current in a series RL circuit, resistance inductance, in which the resistance inductance and voltage are constant. Assume at time 0 current 0. And the formula is given to you in this way. Oh, rearrange, divide by I, rearrange the formula. It look like this. Just a minute. This is linear. Okay, this is my p. I will integrate and take the exponential. We got this formula. Then the current by the exponential equal to the right hand side by the exponential. We integrate, we up here. Then simplify by divided by this exponential. We find the final equation. Now he told me in the question at time 0 current 0. I substituted to find the constant. I'm back to substitute here. This is the general form for the equation. These are some exercises I advise you to practice